Okay, these are the model solutions for this paper. I want you to write an answer for every question I complete, even if you don't understand it at the time, even though I'm explaining it, that's not a problem at all. If you don't like the question, please make sure you put a star next to any questions you don't like. Okay, and question 1 says, fully describe the possible transformation that of triangle A to triangle B. Now, when we talk about transformations, there are 4 types of transformations, and I'm going to go through each one and see if it could be that one. The first one is called a translation. That means that the shape will look exactly the same, it'll just be on a different place on the grid. It's clearly not that one. The next one is an enlargement. So an enlargement does what it says on the tin, it gets large, but it could get half as big, which would ironically make it smaller. And it's clearly not that. The next one, I'm going to say, is a reflection, i.e. it's been reflected in a mirror line. Now, to me, that's looking like that could be the one there. Or, I could have said it was a rotation. Now, I suppose that could have been spun around. I don't know where would be the obvious place, though, between... I suppose maybe there, if I put the thing there and then spun it round by 180, but I'm not certain that. I'm much more confident about the reflection, okay? So I'm going to just put that sign for now, and I'm going to say that there's, because it looks like this is looking back in itself, I'm literally getting my ruler, and I'm finding the middle distance between these two here, which is here, and I'm just going to draw a straight line across with my ruler, and that goes through 1 on the y-axis, so that is y equals 1 line. So I'm going to say it is a reflection in y equals 1. Okay? The next question says rotate triangle A, so make sure you're doing the right one here, triangle A, through 90 degrees clockwise about the origin. So the origin is this place here where the axes meet, and we go and mark it and we put a crosshair over it, and we put tracing paper over and we trace triangle A by here and the crosshair, and we're doing 90 degrees, so that's 1/4 turn, and we're going clockwise the same way that the hands go around on a clock. So I make that, I think it's going to come by here, okay, and then I think it's like that, okay, but you're going to be able to tell me better when you actually use tracing paper. Really hard to do that tracing paper, and you're allowed to use it in the exam. So on our algebra page, and start off with, let's get x on its own. So the last thing that happened to this was it was divided by 4. So to cancel out the divided by 4, I'm going to times both sides by 4. So that's giving me 3x now. 36 times 4, don't really know what that is. So I'm going to write down 36, I'm going to double it, that would give me 72, and then double it again, that would give me 144. And then I'm going to divide both sides by 3. So I think the way we've been writing it in class recently is like that. And again, I don't know what 144 divided by 3 is, so I'm going to do bus stop by here, and I'm going to set up 144. So how many 3's go into 1? How many 3's go into 1? None. So I'm going to write 0 above there. I'm going to cross out and carry it as a remainder. How many 3's go into 14? So 3, 6, 9, 12, 15. 15 is too many, so it must be 12. And 3's go into 12 4 times, and that is a remainder of 2, because it made 3 times 4 makes 12. And then finally, how many 3's fit into 24? And the answer is 8, so my answer is x equals 48. A bit fussier than normal. A lot of these questions here for part B came up in the unitized prep that we did. So first of all, we're going to get rid of the over x by timesing both sides by x. So that's going to give us 9 is equal to 18 times x, which you just say is 18x. And then we're going to divide both sides by 18. So I'm going to say over 18 over 18. That will give me x on this side. It'd be absolutely fine to leave your answer as 9 over x here. 9 over 18, sorry. Or you could cancel that down if you can work out that that is a half is equal to x, 0.5 or a half. Either of those are fine. But this would be full marks by here anyway. Okay, it doesn't say anyway, it needs to be in simplest form, so no need to do these, although they are both correct. And for part C, I'm going to expand this bracket before I even try and do anything else. So I get 5x minus 12 is equal to 3x plus 18. I'm now looking for the smallest x. So what's smaller, 5x or 3x? The answer is 3x, so I want to get rid of it. So I'm going to take away 3x from this side, but whatever I do to one side, I must do to the other. That cancels out those things there, leaving me with 2x. That minus 12 is still there, and that would be equal to 18. And now I'm going to get rid of the minus 12 by adding 12 to both sides. So I get 2x is equal to 30. And now I'm going to divide both sides by 2. And I'm going to get x equals 15. The inequality is exactly the same as doing an equals, but instead of putting an arrow down and putting an equals, I just put an inequality. I'm going to get rid of that plus 5 on each side, so I'm going to take away 5 on each side, and I get 9x is less than 72. And now I'm going to divide both sides by 9. I'm going to get x is less than 8. Okay, the next question here, it says write down the smallest whole number that satisfies the inequality. The first thing I'm going to do is divide both sides by 4. Now there's a bit of a problem there. 45 divided by 4, I don't know, so I'm going to partition it to 40 and 5. I'm going to halve the 40 and get 20, and then I'm going to halve the 5 and get 2.5, and then I'm going to halve the 20 to get 10. I'm going to halve the 2 to get 1. I'm going to halve the 0.5 to get 0.25, which makes a total of 11.25. So I'm saying here that my answer needs to be bigger than 11 and a quarter, 11.25, so the smallest whole number is 12. Okay then, so this one here, we're going to do the numbers. It's the numbers times each other, so 10 times 5 is 50, and then double of that would be 100, so 10 times 5 times 2 is 100, and then x times x times x is x cubed. Okay, this question here is requiring you to know what the word product means. So think of product of prime factors, that means we're multiplying those numbers together. It requires you to know what consecutive means. Now, I'm writing this up just after our trial and improvement lesson that we did on Monday. Consecutive means one number after the other. So 1, 2, 3, 4, 5, 6. These numbers are consecutive. It's the number that comes next in the normal counting pattern. So I could say that 6 is consecutive to 5. I could say 5 is consecutive to 4. I could say 3 is consecutive to 2. But I couldn't say 1 is consecutive to 4 because they're not next to each other. Okay? I could say that 11, 12, and 13, they're consecutive numbers. They're what would come next to each other in any pattern. Okay? So it requires you to know that. And it says find the sum of these three prime numbers. Now, I've got to try and think of some prime numbers that that could times together to make 385. So, thinking of the best way to do this, I would probably write out my prime numbers first. Okay, my prime numbers have got to have, so prime numbers have got to have two factors, itself, and 1. So 1 is not a prime number because 1 only has one factor, which is itself is 1, so it only has one factor. So the first prime number is 2, and that is the only even prime number. Then 3, 5, 7, 11, 13, 17, and 19, 23, and 29. That's the first 10. I doubt whether we'll need to go past there. So from here, I'm going to try and times together a couple of numbers that I think would take me to 300. So if I could pick any 3 to begin with and try a form of trial and improvement. So 2 times 3 times 5. So 2 times 3 is 6, and then times that by 5 will give me 30. So that's way off, so I'm going to try a little bit higher. I'm going to try maybe 7 times 11 times 13. So 7 times 11 times 13. Okay, now I've got a bit of an issue. I don't know what 11 times 13 is. I'm coming to the back end here, but I do know what 11 squared is. 11 squared means 11 times 11, that's 121. So then 11 times 12 must have been 132. And then 11 times 13 would have been 143. So this is like doing 7 times 143. Now that's way too big, isn't it? That's going to take me way past that. 7 times that will be over 700 odds. So I am going to change the numbers that I'm going to go for. I'm going to put a cross next to there. So I'm thinking now that I must be somewhere in the middle between 5, 7 and 11 maybe. So if I do 5 times 7 times 11, so again I'm going to do the back end here. I'm going to do 7 times 11 first, so that's 77. 5 times 77, I'm going to set that up by doing 77 times by 5. And then 7 times 5 here, that's 35, so I'm going to write down the 5, carry the 3. And then 7 times 5 here is 35, add the 3 is 38, and bingo, I've got it. So my three numbers are 5, 7, and 11. But have I answered the question? It says find the sum, so I need to do 5, add 7, add 11. So that's going to give me 12 plus 11, which is then 23. Okay? Quite a tricky one. I had to do some problem solving there, so you're going to have to just look at a question like this and just try and write down stuff you know. I didn't know the answer straight away. I wrote down all the primes and then just started guessing some numbers, and that's what I expect you to do. So there we go. The sum of these numbers are 23. Okay, one of our C grade topics of the week here. So 24, we need to split into a product of its prime factors. So I'm going to do 2 and 12, circle the 2 because it's prime, 2 and 6, circle the 2, and then 3 and 2 circled. So 24 is equal to 2 times 2 times 2 times 3. You don't need to put it into index form for doing highest common factor. And then it says 40, so I'm going to do 4 times 10. Don't need to write down that time sign. And then 4 is 2 times 2, so circle those to their prime, and then 10 is 2 times 5. So I'm going to say 40 is equal to 2 times 2 times 2 times 5. And then I'm going to draw two circles overlapping. This side I'm going to call 24, and this side I'm going to call 40. And I'm going to cross out any numbers that are in both lists. So the numbers that are in both lists are 2 and 2. So cross one out on each list, write it once in the middle, and again 2 and 2. And again 2 and 2. And then what's left on the 24 side is just a 3. So 3 would go by there. And what's left on the 40 side, just a 5. So 5 would go there. So my highest common factor is the bit in the middle, isn't it? It's this bit here. So my highest common factor in index form would be 2 times 2 times 2, which is 2 cubed. Okay, and this question here says calculate the average speed. So as soon as we're thinking speed, we should be thinking of our speed, distance, time triangle. So speed is equal to distance divided by time. I'm asked to work out the speed, so I'm going here to here, and I'm covering the s, so that leaves me with d over t. So I'm going to say that speed is equal to distance over time. I'll just say d over t. They're always going to try and get you this trick. I can already see it. Time is 2 hours and 30 minutes. You need to have it in hours, so it's 2.5 hours, not 2.3 hours. So just be careful with that. And then the distance was 35 miles. So my answer is going to be 35 divided by 2.5. I've got absolutely no idea what that is, so I'm going to times to get rid of this 0.5. So there's a couple of different things I could do. I could times both by 10. If I times by 10, I get 350 divided by 25. I don't particularly fancy working out how many 25s fit into 350 though, so I'm going to try and work slightly smarter, and I'm going to get rid of the times by 10. I'm going to times both by 2. So that's going to give me 70 over 5, and then 70, 5's into 70, I know 5's into 12, sorry, 5's into 60 at 12, and then 65, 70, so that would give me an answer of 14 miles per hour. The next question is requiring you to know a conversion. You should know this. If you don't, make a note to learn it. 1 kilogram is equal to 2.2 pounds. You are expected to know that for the GCSE paper. So if you know that 1 kilogram is equal to 2.2 pounds, and then you're told that her suitcase is 22 pounds, we're trying to find a link between the two. So I can spot that this has been times by 10, so I need to times this by 10, which would give me 10 kilograms. Okay, the way I would answer this question is I'd think of it as two time zones. And I could work out both, or I could work out in one. I'm going to write down Glasgow here, and then I'm going to write down San Francisco here. It's just San Fran for short. Okay, so Sophie is due to fly from Glasgow to San Francisco. She arrives at Glasgow Airport at 13:40 on Wednesday. Okay, she has to wait 4 hours, 25 minutes till her flight. So I'm going to add on 4 hours, 25 minutes. The first thing I'm going to do is add on the 25 minutes. So I'm going to get 14:05, and I'm just a reference by here. And the reason why I'm referencing is because it's a QWC question. So I need to say what I'm doing. So plus 25 minutes. And then I'm going to add on the 4 hours. So 14 add 4 would be 18:05. And that is the flight time. Okay, so just reference there. Flight leaves at this time. Okay. So I've dealt with that. It says it takes 13 hours to fly between Glasgow and San Francisco. Okay, so I need to add 13 onto 18:05. So what I'm going to do is I'm going to add on 12 hours, because that should make it really nice and easy. That will make it 06:05, but obviously now on Thursday. And then I'd need to add on the 1 hour. So that would give me 07:05. But this would now obviously be on Thursday, but this time is in Glasgow. This is the time that she set off from Glasgow. She's waited her time at the airport. She's then flown. So when she arrives in Glasgow, this is what the time is. When she arrives in San Francisco, this is what the time is in Glasgow. So I've now dealt with that as well. It says she knows that the time in Glasgow is 8 hours ahead of the time in San Francisco. So that means I need to take... Now, because of Glasgow being 8 hours ahead, that means I need to take away 8 hours from this time. So I know that if I take away 8 hours from the 7:05, it's going to take me backwards. So I'm going to take away 7 hours to begin with, and that would take me to 00:05. Then I'm going to take away 5 minutes. So that's going to take me to 00, not like that, better, 00:00, and then I'm going to take away 55 minutes. So that's going to put me at 23:05. So in San Francisco, it's still the same day, it's still Wednesday, at 23:05. And then I'm just going to label why I've done certain things. So I'm going to label here that this was the 8 hour time difference. Anything else that I need to do? So this was because flight leaves. I need to highlight that and say that was because it took 13 hours. 13-hour flight. Anything else that I can do on which day and what time does Sophie expect to arrive in San Francisco Airport? Show all your working. I think I have done all that, to be fair. Could I make my answer better? Possibly, yes. I've just done the problem solving thing. But look, I have got a load of space here that I can, if I'm really worried about these marks, come the end of this paper, and I've still got time. You know the time when you finish and you've just got time left at the end of the exam doing nothing? If I wanted to, I would go back and actually write this up and look at it a bit smarter. Okay, so this question here is telling you that you need to draw like a scale drawing. So this is using something called loci. So if you're unsure how to do loci, then what you need to do is you need to go and research that on YouTube. This is massive C-grade marks that we're going to look at after the holidays. You need to be able to do this, okay? I have done sessions before. I'm quite happy to record them again and sit them on YouTube and show us going through all the different types, okay? 30 degrees. We should know how to make 60 degrees. So two ones that you should be able to make is 60 degrees and 90 degrees very easily. 60 degrees, you just make an equilateral triangle. That all has 60 degrees angles. And then for a 90 degrees, you end up getting your compass and you do like two arcs like that and you go through there and it makes 90. So if I'm to make 30, I just need to cut these in half, okay? Which again, you've been shown how to do that. So what you need to do here, you need to look at the scale here, 1 centimetre represents 4 centimetres in real life. So this line here, if that is 48 centimetres there, if 1 is equal to 4 in real life, then this is 48. So I need to divide that by 4 to find this line should be 12. It may not be quite dead on 12 due to photocopying. It will be in the real exam. Okay? Now, what you need to do is open your compass to around about 4-5 centimetres, something you're comfortable with using. And you're putting the point on that line there, and you are going to draw an arc going around like that. Okay? You are now going to put your compass where it's crossed the line by here. And you're going to keep it at exactly the same width, and you're going to draw an arc, and it should be coming all the way around until you hit there. Okay? Now, at this point here where they cross, if I was to join that up, I'll join it up and then rub it out in a second. If I was to join that up there, that would have made 60 degrees. Okay? In fact, actually, you know what? I'm going to leave in the line there, and then I'm going to show how to bisect that line. So, I bisect that line by putting my compass back onto this point here where the two lines cross, and I draw an arc across there. Where it crosses here and where it crosses here, I put my compass in there, keeping it at exactly the same width. I draw an arc inside there, putting the point now over to here. I now draw an arc inside here, and I draw a line going through that point there, and that has now made that 30 degrees. Okay? Now, in terms of how long that line has got to be, I can see there it's supposed to be 40 centimetres. If 1 centimetre is equal to 4 centimetres, then 10 centimetres on my drawing would be equal to the 40 centimetres in real life. So this line needs to be, let me zoom out a little bit. So this line needs to be 10 centimetres long. Okay? We'll stop when it's at 10. Okay, so measure that. It needs to be measured properly. That should be exactly 10 centimetres. Okay, it then says find. So what would that be? This would be the point D by here. It then says find the length of DE. So all you would do now is you would join up D down to the point E, straight line, and you would measure it with your ruler. Now, because I'm doing this on the iPad, I can't actually physically measure what that line is. But you would measure how much it is, and that answer would be in centimetres. Now, that would be on your drawing. So whatever that answer in centimetres is there, so this one here, you would times that by 4 to work out what its actual answer is. Okay? And that would get you the 5 marks. Okay then, so this guy's friend is saying that this frame, the FE, so F to E here, is parallel to G to H. So I'm going to put arrows on to show they're parallel. Okay? Now that means I'm going to have some of my letters come in here, but the only letter I can see here is a C letter by there. I can't see the F, I can't see the Z, and that's because none of these things overlap. So C angles, you should know that angle there plus that angle there is equal to 180 if they are parallel. So if I go and measure what FEH is, I get it at 102 degrees. And then if I go and measure what EHG is, so from E to H to G, this angle here, I measure that at 78 degrees. And I would say yes, because 102 add 78 is equal to 180 degrees. And then I'd say the definition is co-interior. I spelled that wrong. Co-interior. Interior. Slash, you could have used the word supplementary, that's another word, supplementary. Angles add to 180 degrees. Okay, and so I'm going to try and put any information onto the drawing that I can tell from this. It tells me that ADC is 60 centimetres squared. So ADC, so that's A to D to C, that's this thing here. This is what 60 centimetres squared is. And I know that the formula for that would be area is equal to base times height, all divided by 2. Or you could say a half base times height. So I can write down 60 is equal to the base is quite clearly there, 12. So 12 times by the height, which I don't know. So So I'm going to call this h for height, divided by 2. The first thing I'm going to do is get rid of this divide by 2. I'm going to times both sides by 2. So 120 is equal to 12 times by the height. And then I'm going to divide both sides by 12 because the h is currently times by 12. And that answer is 10 is equal to the height. So I know that this height is really 10 centimetres. Okay then, what else does it tell me? It tells me to calculate the area of triangle XBC. So XBC is this one here. But now I know that this is equal to 10. I can now put it through the same formula because I've got a base and a height. I know that's a height because it's a right angle. So again, I'd say area is equal to base times height divided by 2. So I'm going to write it down by here that it would be area is equal to 2.5 times by 10, and then I halve that answer. So 2.5 times 10 is 25, divide that by 2, comes to 12.5 centimetres squared. Okay, the way that we've been doing this is we draw that sort of symbol there, and that tells us to do 5 brackets 20 plus 3x, and then plus 4 brackets 5 minus x, all over 4 times 5, and we just say that is equal to 13 over 4. Okay, then the next thing we're going to do is we're going to expand out these top brackets here, and we're going to simplify this on the bottom. So we're going to get 100 plus 15x plus 20 minus 4x all over 20, and then that is equal to 13 over 4. Okay, the next thing I'm going to do is get rid of that over 20, so I'm going to times both sides by 20. That's going to give me 100 plus, in fact actually let's not write 100 plus, let's try and simplify it. So I've got 100 plus 20, that is 120. I've got 15x, take away 4x, that gives me plus 11x. And I can say that is equal to, I need to put a 0 there, to 13 times 20. And then I divide that answer by 4. Okay, so what is 13 times by 2? Well, that answer is going to be 26, isn't it? But then I need to put a 0 on the end. I still need to divide that by 4. I've still got 120 plus 11x this side. And then I'm going to get 120 plus 11x is equal to half of 260 is 130. And then half of 130 is 65. I'm now going to take away 120 from each side. Now that's not the easiest question in the world. So I'm going to do it the other way around by here. 120, take away 65. And that answer comes to 5 and 7. It comes to minus, is equal to minus 75. Okay, and so the first question here is substitution bit. So we're going to change the x's to open brackets there. And again here, let's just get ready so we can do it nice and quick. And let's do the positive one first. It'll make things a bit easier. So we're subbing in x is equal to 2. So this, you must follow the word BIDMAS to do this correctly. So BIDMAS tells you to do brackets, then the indices. So I'm on this one here. So 2 squared is 4. And then 4 times by 3 is 12. And then 12 plus 2 is 14. And then this one here is going to be minus 2. But the good news is minus 2 squared is minus 2 times minus 2, which is plus 4 times by 3 is 12. Add 2 is 14. Okay, next we are going to plot those points on the graph. We're going to have to put our own scale in here. So let's try and make it easy. I don't want to go up past 14 really. So I'm looking there. Can I go from 2s? 2, 4, 6, 8, 10, 12, 14. Yeah. Okay, so 14 there, 12, 10, and so on. Okay, and then this one here, obviously, minus 1, minus 2, and then 1 and 2. So minus 2 and 14 there, and then minus 1 and 5, so that would be in the middle, and then 0 and 2, so physically there, and then 1 and 5, and then 2 and 14. Now the thing that you should know is that these make smooth curves, so you don't draw straight lines like this. You don't do that. If you've done that with a ruler, that's wrong. You need to redo it, okay? It's got to be a smooth curve. Now I tend to stop the bottom, what we call the minimum point, and then go up by here, but you should really try and do it in one go. It makes it a much smoother curve. Okay. Okay, where this is talking about the gradient being 0, we're looking for my graph. So here would be really, really steep gradient, then less gradient, then here is 0 where it's flat. Gradient 0 just means flat graph. Okay, so looking back at the graph, it would be 0 and 2. That's where it's at its flattest. Okay, the next bit's quite tricky. What it wants you to do, it wants you to draw an XY table for this graph here, for this y equals 2x plus 5. So if I do x, and I'm going to choose any 3 numbers, which I'm going to choose 1, 2, and 3, and then y is equal to 2x plus 5. So here, I'm going to do 2 brackets plus 5. Here, I'm going to do 2 brackets plus 5. Let me make that look a bit better. 2 brackets plus 5, and then here I'm going to do 2 brackets plus 5, but this is going to change because x here is 1, so that's 2 times 1, which is 2, add 5 is 7. Here this is 2 that goes in there, so that's going to be 2 times 2, which is 4, add 5, which is 9, and then finally I'm going to get subbing in the 3 by here, and I'll get 6 plus 5, which is 11. So I need to go and plot 1, 7, 2, 9, and then 9, 11 back on the previous graph. Okay, this question is for a probability tree, and it usually sets it up for you, but you're going to have to set this one up yourself. So it says, a fair dice is thrown twice. What is the score is noted each time. Calculate the probability of getting at least 1 6. So your branches need to be as follows. It needs to be 6 and not a 6. The chance of me getting a 6 is 1 out of 6. The chance of me not getting 6 is 5 out of 6. These two numbers on the top, 1 add 5, should add to one of the denominators. So 1 add 5 is 6, 6 out of 6, and that tells you that the branches add up to 1. Now if I get a 6, I could throw again, and I could get a 6 and not a 6. And I could get a 6 and not a 6. And again, the probabilities remain exactly the same. It's 1 out of 6 on each of those, and then 5 out of 6 on each of these. Now what you do in between the branches of a probability tree is you multiply the numbers together. So some people like to go and put time signs in between. So this would be 1 out of 6 times by 1 out of 6. That is 1 out of 36. This would be 1 out of 6 times 5 out of 6, which is 5 out of 36. This would be 5 out of 6 times 1 out of 6, which is also 5 out of 36. And this would be 5 out of 6 times by 5 out of 6, which is 25 out of 36. If I go back and do that last check, 25 add 5 is 30, add 5 is 35, add the 1 is 36, and that is the same as the denominator. All of your probabilities should do that. It's telling you that all probabilities add up to 1. Now, the question's asking me, what are the ones, or what is the chance of getting at least 1 6? So in this option here, where I've gone 6 and then got 6 again, I got at least 1 6. This option here, getting 6 then not a 6, was also, I got at least 1 6. This option here, not a 6 but then a 6, that also got me at least 1 6. And then this option here, not a 6 and not a 6, that doesn't get me 6, so I'm not interested in it. So that means I'm interested in these probabilities, and what you do is you add them together. So 5 out of 36, add 5 out of 36, add 1 out of 36, which comes to 11 out of 36. Okay, then for part B, it talks about relative frequency. Relative frequency, you need to learn a formula, which is relative frequency equals number of successes, over total trials. Okay, the total number of times you do something. So if you look at this column here, that is getting that's got purely just by adding these numbers to the last numbers. So 4, and then this is 4 add 3 was the 7. This 9 was the 4 add 3, which is 7 add the 2. This 12 was the 4 add 3 add 2 add the 3 there, and so on. So this 20 here, I just need to add on 4 to the side, so I'm going to get 24. Then I need to add on the 3, so that's 27, and then I need to add on the 2, so that's 29. This gives me 24 out of 80. This gives me 27 out of 90. and this gives me 29 out of 100. To then change those into decimals is not the easiest thing in the world. This one maybe is 0.29, but the other ones I need to actually go and work out what they are. So 27 out of 90. I'm going to change that to 2.7 divided by 9, and then I'm going to do the bus stop of 2.7. How many 9s go into 2? The answer is 0. And then remainder 2. And then into 27 is 3. So that answer is 0.3. I'm going to do exactly the same for the 80. So 24 out of 80, I'm going to change to 2.4 divided by 8. And then I'm going to do 8 into 2.4, which again works out to being 0.3. Okay, with this graph, I just need to plot all those decimals against the number of trials that I had. So just keep on looking back at your previous page to plot them. So I'm not going to show how to plot those points. The one thing I will double check is checking the scale here. 0.1 in 10 jumps, it gives me 0.01. Okay, so I'll plot those points and then I'll talk you through what we need to do. Okay, so I've plotted the points as totals. In terms of joining those up, you could join them up. I'm not going to bother joining them up, but you could. And what relative frequency does is it's probability in practice. So, for instance, if I was to roll the dice 6 times, the chance of me getting each number once, if I threw it 6 times, I'd expect to get 1, 2, 3, 4, 5, and 6. Relative frequency is actually going and physically rolling that dice 6 times and seeing if that actually happens, which, as we all know, probably wouldn't happen. But what we do expect is the more times you do it, so for instance, if I rolled them 300 times, then I would expect to get 50 ones, 52s, 53s, 54s, and so on. If I did do that experiment and then say the number 6 came up like 200 out of the 300 times, then I'd say that dice is what we call biased. It's not a very fair dice. It says, using the above results, write down the best estimate for the probability of not obtaining 6 on Carwin's dice. So the chance of him not obtaining 6, well, I can tell you that the chances of him throwing a 6, the best one I can give is the more number of trials. More trials suggest more accuracy. So the chances, or best chance, of getting 6 is 0.29. So that of not getting a 6 would be 1 take away that. Not a 6 would equal 1 minus 0.29 because all probabilities add up to 1. So what do I add to 0.29 to get up to 1? Well, first of all, 0.01 would take me up to 0.3 and then 0.7, so it's 0.71. Okay, then finally it says, Carwin says that the dice is not a fair dice. Explain why Carwin's statement could be true. Well, if you've got a 10-sided dice, I'd expect 6 to come up once every 10 times. So once every 10 times is equivalent to 0.1. And we've just gone and found out the chances of him getting a 6 is 0.29. So that is what I call my expected probability here. This thing. Expected probability. Whereas in 100 throws, he achieved a relative frequency of 0.29, so much higher, nearly 3 times higher. So I would say that it probably isn't fair dice. There's only one way to find out, and that's to do more experiments. More experiments would mean greater consistency. Okay, the first question, it says, how many of the 800 callers took less than 15 seconds to get through? So here's 10. That means 15 must be here. And I'm looking to get to the first call line. So I'm going to draw a line up, still through to there. And then reading off, I find that there are 300 people. 0 to 300 is 300 people. Okay, so 300 is the answer there. Okay, I'm starting to complete some of the work for part B now on this slide. Okay, so I've already gone and found out that 80% of their calls would have come to 320. So what I need to do is draw a line at 320 until I hit the help for you graph, which is by there. And then I'm coming down to read off what that value is. So I make that 20 point, no, I make that 21 actually, because if that's 30, each little square is worth 1, so that's 21. So plotting the medians now, I go and look at the graph. I go and find where its highest cumulative frequency is, which they're both on that point there, which is 800. So the median would be half of that, which is 400. So draw a straight line across, come down, read off what those values are. So 20 and 25. Okay, so then I'll do some work with that on the next page. And for the interquartile range, I need to know what the lower quartile is. So if the median is 400, the lower quartile will be half of that, which is 200. So come off, hit the graph in 2 places. So the first one's really easy, it's 10. For the next one, I make that 13. Now what I would recommend you do is just reference what your lines are. So we've got the lower quartile there, got the median there, and I'm going to do the upper quartile. So the way I work out the upper quartile is I look at what the median value was, 400 and 200, and I add those together. And effectively that works because it is half, add a quarter is 3/4. So now I'm going to draw a line across at 600. In fact, I'm going to draw that a bit better. You're going to use a ruler. There and there. So I can see this one is particularly nice. It's at 40. This one's not too bad either. Oh, there we go there. So that'll be 35. Okay, and again, reference what that line is. So that's the upper quartile. Okay, and the first thing I do here, it says their target was 40% of calls in less than 25 seconds. They actually met the target with these 800 calls. So I'm going to work out what their target was. So target would have been 40% of 800. So 10% be 80, 20% be 160, and then 40 would be double of that, which would be 320. Next, okay, so what I need to do now is I need to go and find where 320 callers are on the y-axis of the previous graph, draw my line across, and then come down and find out how many seconds 320 people did. Because the question was, by how many seconds did they beat their target? So as you have already seen, I've gone and drawn a line off at 320 on the y-axis until I hit my line, and that gave a value of 20.5 seconds. So I need to do 25 seconds. I need to take away the 21. So 25 seconds, take away 21 seconds would be equal to 4 seconds. Okay, so for the lower median time, you should have seen me already plot the lines to that. So I'm just going to read off what those values were. So the medians were, for first call, it was 20 seconds. And then for the other one, Help For You, it was 25 seconds. So that means that first call, they were quicker. First call quicker by 5 seconds. Okay, and to work out the interquartile range, you need to know a formula, and that is interquartile range is equal to upper quartile, take away the lower quartile. The upper quartile is 3/4 of the cumulative frequency, whereas the lower quartile is 1/4 of the cumulative frequency. So for first call, I would get an upper quartile of 40, take away a lower quartile of 10, which gives me an answer of 30 seconds. Whereas for the other one, for the Help For You, I would get an upper quartile of 35 and a lower quartile of 13. And 35 take away 13 is 22. If you're unsure, maybe do that by the side. 22. And 22 seconds. And it says, finally, it says, one of these companies was given an award for the speed of answering a telephone. Which company do you think won the award? You must give a reason for your answer. I would probably go with the one with the quickest median time. So I would choose first call. So first call, because the median is an average, because the median, in brackets, average time, was 5 seconds quicker. Okay, I'm going to show you how to do this bit here because the first bit is actually quite similar to stuff you've done before. We're going to do that thing there, and that tells us to cross multiply. So we're going to say 4x plus 3, and then we're going to multiply it by the 3x plus 1 from there. So that is that times by that. The next thing I'm going to put in is the minus sign from here, and then I'm going to say it's the 6x minus 5, and then it is the 2x minus 1, and then I'm going to put that all over the 2x minus 1 times by the 3x plus 1. Okay? Now, there's actually no need for you to go and expand out the bottom. You can leave that completely alone. Okay? There's no need to do anything there. But you need to expand out these brackets here. So you're going to do 4x times 3x, which is 12x squared. You're going to do 4x times by plus 1, which is plus 4x. You're going to do 3 times by 3x, which is plus 9x. You're going to do plus 3 times plus 1, which is plus 3. Okay? The thing you've got to be super careful with in this question is this is minus, and now you need to put this blue thing that I'm expanding all in one bracket, and then we need to times it by minus. This is where people will lose their marks. So 6 times by 2x is 12x squared. 6 times by minus 1 is minus 6x. Minus 5 times minus 5 times by 2x is minus 10x. And then minus 5 times minus 1 is plus 5. Okay? Now, what that minus outside the bracket here, what that's going to do is going to shift all of these to its opposite signs. Okay, so I'm going to get the first thing's going to remain exactly the same. It's 12x squared plus 4x plus 9x plus 3. But this minus by here is going to change all of these to its opposite signs. So it's going to become minus 12x squared. It's going to become plus 6x. It's going to become plus 10x. And it's going to become minus 5. And that is all over still the same thing that you don't need to expand out. So we get 2x minus 1 and we get 3x plus 1. Okay, so now we're going to get 12x squared. Any more x squareds? Yes, here. 12x squared minus 12x squared is going to cancel completely. Then I'm going to get a 4x plus a 9x, so that's 13. Plus a 6x, that's 19x. Plus a 10 will give me 29x. So I've counted all of those now. I'm not going to cross them out because they didn't cancel. I'm just going to tick and say I've counted them. And then I'm going to get a plus 3 minus a 5. And a plus 3 minus 5 is minus 2. And that is all over 2x minus 1. And then 3x plus 1.